Welcome to The Explainer. So glad you're joining us. Today, we're diving headfirst into something we all use literally every single day, but kind of take for granted: the hidden mechanics of our digital world. I mean, we're on it for work, for laughing at memes, chatting with friends, but honestly, almost nobody knows what's actually happening under the hood. Well, today, we're going to change that.
Think about it for a second. How is this exact data reaching your eyes right now? You clicked a link or pressed play, and somehow, in literally less than a single second, the information traveled from a computer somewhere, bounced through who knows how many machines, probably crossed vast oceans, and landed perfectly on your screen. When you stop and actually think about it, it's absolutely insane. So here's my promise to you. We are going to solve this mystery of the internet together, and we're doing it by completely ditching the boring tech jargon. We're going to focus purely on the real, simple, and frankly, utterly fascinating story of how this whole shebang actually operates. Okay, let's kick things off with Section 1, the physical internet. Myth versus reality.
Here's what most people think. They picture the internet as this magical, invisible cloud floating somewhere up in the sky. Nope. Not even close. The reality is, the internet is literally just a massive network of computers connected to each other through physical cables. We're talking fiber optic cables, copper wires, and this is the crazy part, hundreds of thousands of kilometers of massive cables running right along the bottom of the ocean, physically tying entire continents together. It's honestly best to think of it exactly like a global postal system, except, instead of physical packages, it delivers data, using signals traveling through those cables at nearly the speed of light. And here's a totally mind-bending fact for you. Nobody actually owns this postal system. No single company, no government. It's just this massive shared agreement between millions of different networks around the world, all playing by the exact same set of rules or protocols like TCP/IP, just so they can talk to each other. Moving right along to Section 2, finding the address, your home on the internet. So, every single device on the internet gets its own unique IP address. We're talking your laptop, your phone, heck, even that fancy smart fridge in your kitchen. It usually looks like a clunky sequence of numbers, something like 192.168.1.1. And just like your actual physical home address, if a website wants to send you data, it absolutely needs to know exactly where you live in the digital world. But let's be real, we don't memorize long strings of numbers for every site we visit. Nobody's got time for that. This is where DNS, the domain name system, steps in as the internet's ultimate phone book. When you type in something easy to remember, like youtube.com, your device asks a DNS server, and in mere milliseconds, it instantly translates that typed name into its matching IP address behind the scenes. You never even notice it happening. All right, Section 3, traveling in packets, the journey of data. When you request a web page, that message doesn't just travel as one big, heavy chunk. That'd be way too slow. Instead, the internet efficiently breaks it down into these tiny little pieces called packets. Each packet essentially hops from one router to the next, finding its own absolute fastest path through the global network before finally reassembling at the destination. It is exactly like this quote says. Imagine if you took a physical letter, tore it into 50 pieces, mailed each piece separately, and somehow they all arrived and put themselves back together perfectly. And the wildest part? Different packets from the exact same request might take completely different routes. Like one packet might fly through Europe, another through Asia, and they still meet up at your screen like absolutely nothing happened. Now, you might be wondering, how does this not just descend into total chaos? Well, that is all thanks to TCP, or Transmission Control Protocol. Think of TCP as the internet's super strict quality control manager. It's the vital system overseeing this entire chaotic journey, making sure that every single one of those torn up digital pieces actually shows up, doesn't get lost in transit, and gets put back in the exact right order. Which brings us to Section 4, servers and browsers, translating the code. So where do these flying packets actually come from? Well, when you type in a URL, you're essentially walking up and knocking on a server's door. And a server is really just a powerful computer that's always on and always connected to the web. It stores all the files that make up a website. So you ask to see the site, the server checks its files, and then fires back all its text, image, and video files inside those tiny packets we just talked about. Then we have your browser. Whether you're a Chrome fan, Safari, Firefox, whatever, it's basically a high-speed translator. It catches those assembled packets of raw code, your HTML, CSS, JavaScript, and instantly translates them into the beautiful clickable page you're looking at right now. And remember, this entire conversation between the server and the browser, it happens in just milliseconds. Let's look at Section 5, Security, keeping the journey safe. With all these pieces of data flying globally through so many different machines, you might naturally ask, couldn't someone just intercept it? In theory, yeah, they could. And that is exactly why we rely heavily on encryption, specifically SSL or TLS encryption. What this does is scramble your data before it's ever sent, turning everything into total gibberish. Even if someone manages to snatch your packets mid-journey, it's totally unreadable because only the intended destination has the digital key to unscramble it. It's literally like sending a letter in an unbreakable lockbox. And this right here is why the HTTPS in your web address is absolutely critical. That S literally stands for secure. Verifying that little padlock icon in your browser guarantees your sensitive info, stuff like your passwords and credit card numbers, is wrapped tightly in that lockbox. Always check for the lock, folks. Finally, Section 6, the true scale. Let's look at some mind-blowing facts. 5 billion. Every single day, over 5 billion people are actively using this massive physical network of cables and servers. That is well over half the population of the entire planet, all interacting on this one shared system every single day. 200 million. That's the number of emails sent globally in just 60 seconds. In that exact same 1 minute, people are also firing off 40 million WhatsApp messages and streaming about 700,000 hours of video. The sheer volume of packets flying around at any given second is just staggering. And yet, 50 grams. Despite its massive global footprint and billions of users, if you were to somehow weigh all the actual electrons moving through the entire internet's infrastructure at any given moment, the whole thing weighs about 50 grams. That's roughly the weight of a single strawberry. I mean, no way, right? But it's true. It's just incredible to think about how far this has all come. This whole system has been building steadily since 1991, when the very first website was created by Tim Berners-Lee, the inventor of the World Wide Web. And amazingly, that very first website, it's actually still online today. It's undeniably one of the most impressive things humans have ever built. We use it without thinking twice, but the next time you type a web address and hit enter, I want you to remember what's really happening under the hood. The internet happens in milliseconds, but how much of its invisible journey across oceans, through digital lockboxes, and reassembling from tiny fragmented packets will you notice tomorrow? Just think about that incredible journey of a single click. Thanks so much for joining me for this explainer. Keep learning, stay curious, and I'll catch you in the next one.